Hello, algebra students. We are going to talk about absolute value inequalities today, but let's tie it into what we've been doing. We were working with compound inequalities, and we had two different compound inequalities. We had some that we called the and they were typically line segments on the number line. Those are your and compound inequalities. And we had a second type that were the or. And usually they looked like rays shooting off, and it could be different circles, but in different directions. So we had and or compound inequalities. Well, we're actually going to use this information with the absolute value inequalities. How are we going to do this? Let's take a look at, it's pretty cute here. Greater, when you have a greater than inequality symbol, you can think of greater. That is going to be an or inequality. Less than, you can think less than. Isn't that great? Less than, and that's going to be your and inequality. So that's a little trick that'll help you remember greater and less than. And then you'll get a game plan what your graph should look like when you end up solving it. And we will take a look at a couple problems right now. All right, so here, example number 1, we're looking at the absolute value of x plus 3 is less than 12. You need to be careful here. It does have this symbol initially, but let's not say this is and yet. We need to isolate the absolute value bars, just like we did with equations, with inequalities. You need to isolate the variable and here the absolute value. So we're going to subtract 3 from both sides to get it all by itself. 3's will cancel. We're left with the absolute value of x is still less than 9. Okay, now you take a look at the inequality symbol once the absolute value bars are isolated, and I can see this is a less than or less than inequality. So I know I'm going to end up with a line segment when I end up graphing this. Okay, so the absolute value of some unknown number, so you can think the distance from 0 has to be less than 9 units. The distance from 0 has to be less than 9 units. So if we were to solve this algebraically, we go back to the x is less than 9, and the opposite of x is less than 9. X is less than 9 is already finished. We have to divide by -1 here, divide by -1, and we get x, flip-flop, is greater than -9. Okay, algebraically, that's how you solve it. Now let's look at the graph. The graph, we have -9. I'm going to follow through here with a compound inequality. +9, 0 in the middle. We have 9 units this way, 9 units this way, so it's our line segment. Open circles and all this in here. The compound inequality, let me give myself some more room here. Extend page. Okay, so x is less than 9 and greater than -9. So make sure you put the smaller number on the left. X falls somewhere in between, the larger number on the right. X has to be greater than the -9 and less than the +9. So we can see it's an and compound inequality right here. We have an and line segment graph, and that's absolute value inequalities.
Hello, everyone. This is Mr. Auble hopping in with the second problem. So, as Ms. Vaughn said on the first problem, we cannot tell for sure whether we are going to have a less than and or a greater or until we have that absolute value quantity all by itself. So I have some work to do first. So the first thing I'm going to do is I'm just going to treat it like a regular equation. I'm going to add 4 to both sides, and that's going to give me 2 times the absolute value of x minus 3 is greater or equal to 2. So far it looks good. And I still have to isolate the x minus 3, so I'm going to divide both sides by 2. So that's going to give me the absolute value of x minus 3 is greater or equal to 1. So I'm ready now to analyze it and make a decision whether it's going to be a less than or a greater. And in this case, it's got a greater than symbol, so it's got to be a greater. So I'm going to go ahead and get started with this. I'm going to break apart the absolute value, and I'm going to have x minus 3 is going to be greater than or equal to 1. But this time, instead of using and, such as a greater, I'm going to put or. We have the opposite of x minus 3 also is greater than or equal to 1. And so now I have the one on the left is a little bit easier to solve. So I'm going to have x is greater than or equal to, if I add 3 to both sides, I get 4. Or on the on the right side, I have to divide both sides by -1. Uh-oh, that divide by negative thing. So I'm going to have x minus 3, but instead of being greater, I'm going to switch it around to less than or equal to. And 1 divided by -1 is indeed, it's -1. And at this point, then I need to go ahead and add 3 to both sides. Add 3. And I end up having x is less than or equal to a positive 2. But if you leave that as your answer, you are not going to get full credit for that particular problem. You have to actually write the solution. So in this case, I'm going to write out, I'm going to start with x is less than or equal to 2, or x is greater than or equal to 4. And now I'm ready to go ahead and try and graph this thing. So just like Ms. Vaughn did on the previous slide, let me get rid of a little of this work here she has from the previous problem. I can set up my graph. Here's my number line. And I have 0, 1, 2, 3, 4, 5. I just put a few numbers on either side of my solutions. And the one graph is going to be x is less than or equal to 2. So I'll put a solid circle here at number 2. Less than goes off to the left. And then I do the same thing on the other side. X is greater than or equal to 4. And so I have a solid circle at 4. And my graph is going off to the right. Now, if we go back to, remember our equations, we talked about what was really going on. I'm going to scroll back up a little bit, right to here. Remember before when we were talking about absolute value equations and we had things like absolute value of x minus 3 equals 1, we were talking about the numbers that were going to be 1 unit away from 3. Okay? So in this case, let's look at this. 1 unit away from 3, here's 3. 1 unit. There's 1 unit, it gets me right to 4. And if I go to the left, 1 unit away, it gets me to 2. So it makes sense that my boundary points would be at 2 and at 4. And then the other thing, though, is what's different about this, instead of being equal to, we're really talking about greater than. So we're talking about being farther away or equal to 1 unit away. So 1 unit away is at 4, and it's also at 2. But we're talking about greater, so that's why we go off to the right and we go off to the left. So that's the solution then for this second example. All right, I've got a couple more examples to show you, and you know, those who see Ms. Vaughn or me in class, we don't just get by with just the easy ones. We always have to throw something, a little curveball at you. So if you look at the one on the top left part of the screen, it looks like at first glance, hey, it's greater than, it must be an or, right? Well, if you thought it, you'd be wrong. So I'm going to go through here, and I'm going to do something right now and actually do exactly what we said before. We have to isolate that absolute value all by itself, because if we don't, we're going to make mistakes. So my first step here, once again, I'm going to subtract 5 off the left, off the right, and then I'm going to have absolute value, the negative or the opposite absolute value of x is greater than -2. And then we're looking at, well, -2, that seems kind of weird. Do I stop? Do I do no solution? What do I do? Well, no, wait a minute. Look, there's still that negative out in front of the absolute value, so I can't make my analysis just yet. So I'm going to divide both sides by -1. And now I end up having the absolute value of x. We have to do the switcheroo because we're divided by -1. Is now less than a positive 2. Okay, I feel better now. I've got an absolute value. It's a less than, and it's going to be less than a positive. I feel pretty good about this right now. So I'm going to go ahead and break it apart. Less than, if you remember, means and. So let's go ahead and break it apart. And I'm going to have x is less than 2, and opposite x also is less than 2. Now the left one's already solved, so I'm done with x is less than 2. The one on the right I have to divide by -1. So I'm going to get x is greater than -2. So I'm going to go ahead and write my solution down in the compound inequality form before I do my graph. So I'm going to do what Ms. Vaughn said. I'm going to put the negative number all the way to the left. I'm going to put the x in the middle. I'm going to put the larger number all the way to the right. X has to be less than 2. X also has to be greater than -2, so they're pointing in the same direction. That looks pretty good to me. And I'm looking for the common segment between 2 and -2. So I'll just do a real rough graph. -2 is off to the left. +2 is off to the right. We're talking about less than and greater than, so we must be talking about an open circle, not a closed circle. And then I'm going to go ahead and graph right between them. And there's my solution for this particular problem. But remember, if you had just gone ahead right at the beginning, and I'll scroll back up, and you looked at the greater than and said, oh, it's got to be a greater, you would have been wrong, and you've been very frustrated with what's going on with your answers. So let's go ahead and take a look at the second problem right now before we finish this first video up. Again, it's another one of those sneaky ones. It looks like a less than, and then it also has a negative there, and that looks kind of confusing too. But remember, you can't make any decisions until you get the absolute value all by itself. So I'm going to go ahead and do it. I'm going to add 4 to both sides. So now I have -2 times the absolute value of x is less than or equal to -2. I'm still not going to make any decision because I have to divide both sides by -2. So now I have absolute value of x. I have divided by a negative, so I have to do the switcheroo. Instead of less than or equal to, it's going to be greater than or equal to. And -2 divided by -2 is 1. So now I look at it, the absolute value is all by itself. It's greater than or equal to 1. So it looks to me like I can actually draw a graph and solve this particular problem. So greater means or. So I'm going to write it down. X is greater than or equal to 1, or the opposite of x is greater than or equal to 1. And when I solve them, the left one is already solved. So I have x is greater than or equal to 1, or I have to divide both sides by -1 on the left-hand side. I'm sorry, on the right problem right there. And I end up getting x. Since I'm divided by negative, I have to switch it around. And I'm going to have x is less than or equal to -1. So now here is my solution. And I'm going to have that or statement in there. If I don't put the or in there, you are not going to get full credit for your answer. You must have the or. Just like if I go back to the previous problem, you're not going to get full credit unless I have it written as a compound inequality, like the blue one I just circled. So let's finish up the problem on the right, and let's go ahead and draw a graph. And so I'm going to do another rough graph like I did before. So I've got -1, 0, and 1. So I'm talking about the value x is equal to 1 or greater than 1. So I'm going to pick up a different color. And I got a nice purple one. This is over Mrs. Smith. She's got a nice purple color on hers. So I'm going to go x is equal to 1, but it's also going to go off to the right because it's greater than. And then I go to x is -1, and it goes off to the left because it's x is less than or equal to. So that would be the solution to and the graph of x is greater than or equal to 1 or x is less than or equal to -1. So we're going to come back in our next video, and we're going to give you some problems, some applications, and some other kind of crazy ones that we looked at. You remember in class we looked at the ones where there's some no solutions and all real number type problems. But that'll be on the next one. Thanks and have a great day.